Hey guys, we're on Unit 8 and this is day 4 and we're going to do more with our right triangle proportions. So in our warm-up it says that the altitude is drawn to the hypotenuse of a right triangle. And when it says that, we're going to think of our picture looking like the right triangle that fell over, the right angle up in the air, okay? And then this being the hypotenuse on the bottom. Okay? It says that if the altitude drawn to the hypotenuse, so the altitude goes from right angle and then makes more right angles. And they're saying that that altitude has a length of 10. Okay? The lengths of the segments of the hypotenuse, so when that altitude came down, formed two segments here on the bottom. They're called projections. Okay? And they're wondering what those segments could be. So we don't know this one. And we don't know this one. I'm going to call them different letters because they're probably going to be different lengths. Okay. And we know that this is called a projection 1 and this one's a projection 2. And anytime our problem has to deal with the altitude, we know our proportion is pigs are awesome pets, and those projections are different. So when we go ahead and we sub in our first projection, we called x over our altitude, which we called 10, is equal to our altitude, which is 10, over our projection 2, which we called y. And so when we cross multiply, our two projections, when multiplied together, have to equal 10 times 10, which is 100. And so if I take 3 and 7, that gives me 21, which isn't equal to 100. 50 times 50 is not equal to 100. Okay? Equals 2500. Okay. Number 3, 2 times 5 is 10, which is not equal to 100. And in number 4, 5 times 20 is equal to 100. And so if this has a length of 5 and this is a length of 20, when we put that 5 and that 20 in, 5 times 20 gives us 100. And so this is our answer. All right, let's take a look going down, just a little bit of a review. Okay. It says when an altitude is drawn to the hypotenuse of the right triangle, the hypotenuse is divided into two segments called projections, and the large triangle is divided into two subtriangles. Okay? And we know that all three right triangles in this picture are similar to the original and similar to each other. Okay? So remember that this whole hypotenuse here is on the bottom. The legs are up here now, and we call that one a 1 and that one a 2 to denote them. Then the altitude is drawn in, and the altitude, when it hits the hypotenuse, splits it into two pieces called projections. Okay? And because this is a 1, we have to make that a 1. That's a 2. We have to make that a 2. Okay? All right. We know that because the triangles are similar, that their corresponding side lengths can be put into a proportion. Okay? And we already know pigs are awesome pets from the day before and up in the warm-up. And now we're going to learn another proportion that works. Okay? And so this one is the projection 1 over the leg 1 is equal to the same leg 1 over the whole hypotenuse. Okay? Or the 1s can be replaced with 2s, and you could use projection 2 over leg 2 equals leg 2 over the whole hypotenuse. And so to remember these, we use the little way of remembering a mnemonic device called pigs love low hurdles. So we say pigs love low hurdles. And then depending on what's in your problem, you can have all of these being 1s, like the first proportion, or if you're dealing with leg 2 and projection 2, then we'll change them all to 2s. All right, so hopefully that will help you remember, along with pigs are awesome pets, that these two proportions, okay, work on the picture we've been looking at, okay, with the right triangle and his altitude drawn to the hypotenuse. So number 1, it says that JH is 5 and that HL is 4. And they want us in part A to find KL, so we'll put an X on it. Okay. So looking at my picture, because I'm solving for X, I have to know that this is a leg 2. That makes 4 a projection 2. And it makes 5 a projection 1. Okay. Notice there's nothing on our altitude. We're not asked to solve for KH, and we have no information on KH. And therefore, we're not using pigs, our awesome pets. We're using pigs love low hurdles. And based on what we have in our problem, we got the 2's. So we're going to use projection 2 because we have leg 2 is what we're solving for. So now we can go ahead and say, all right, projection 2 comes out, 4 goes in, leg 2 comes out, X goes in, equal to the same leg 2, which is still X, over H, which is the whole hypotenuse, which you have to remember is the 2 projections added together, and that gives us 9. And so now we can replace the hypotenuse with 9. We'll go ahead and cross multiply. X times X is X squared, equal to 4 times 9, which is 36. We'll take the square root of both sides, and X comes out to equal 6. And therefore, KL equals 6. Okay, all right, so now in part B, they're asking us to find JK. So we'll go ahead and we'll call this Y since we already used X, and we have to know that that is our leg 1. And again, we have nothing on the altitude. We're not asked to solve for it, no information, so we know we're not using pigs are awesome pets with the altitudes in it. We're going to use pigs love low hurdles again. Except because they're asking me to solve for Y, which is a leg 1, we make the leg 1's 1s, therefore the projection is a 1. And now we can go ahead and replace. Projection 1 is 5 over leg 1, which is what we're solving for, and we called it Y. Same leg 1, so same Y. And whole hypotenuse, we already added the 2 pieces together to get 9 in the last problem, and it's still going to be 9. When we cross multiply, we get Y squared equal to 5 times 9, which is 45. We take the square root, but this time it's not perfect. And so we'll go ahead and we'll break it up into the largest perfect square that goes into 45, which is 9. The other number being 5. We'll circle the perfect, and we'll finally say in our simplest radical form, our answer is 3 square root of 5. And therefore, JK equals 3 square root of 5. And that one's done. All right, I'll see you guys on the back side of notes.